Time for some acceleration problems. If you look at your formula sheet where it says kinematics, there are 4 new formulas. Okay, so we're going to try some problems with those. All right, let's take a look at what these symbols actually mean. Okay, so if you look at your formula sheet, you have symbols like V, V naught, A, T, and X. Okay? So when we see V, V is going to represent final velocity. Traditionally, the units that we use, you'll see mostly in physics, are meters per second or kilometers per hour. If you were driving in your car, it would be miles per hour. Okay? That's the final velocity, where it ends up at. V naught is the initial velocity of an object. Okay, what it's starting out with. A lot of times these problems are very tricky because it'll say an object starting at rest. If it's starting at rest, your initial velocity is going to be 0. Makes the problem a lot easier. Sometimes you'll see final velocity is 0. If it comes to a stop, okay, then your final velocity is just 0. A is your acceleration, okay? A is your acceleration. The usual units for that are going to be meters per second squared. T is time. It's a lowercase t. And X is your horizontal displacement. In some problems, you'll just see the word distance, okay? But you're trying to find the horizontal position or the horizontal displacement. Okay, it's usually going to be in meters. You might see it in centimeters sometimes or kilometers, but traditionally in physics we're using metric units most of the time. So those are going to be the variables that you see in all of these kinematics equations. Let's look at the first problem. A ball starting from rest accelerates at 6 meters per second squared down an inclined plane for 2.5 seconds. What is the velocity of the ball at the end of the 2.5 seconds when you're doing these problems? And you're starting out new with these. Let's list all the variables we have, the knowns and the unknowns. Okay, so a ball starting from rest. I told you this a few seconds ago. What happens at rest? Well, we've got an initial velocity, v naught, so it's going to be at rest. So our v naught is going to be 0 meters per second. And it accelerates at 6 meters per second squared. So our a value, is 6 meters per second squared. And then it travels for a time of 2.5 seconds. Okay? And I want to know, what is the velocity of the ball at the end of it? So what is its final velocity? What is v? Okay? At the end. So if you look at your formula sheet, you've got a formula sheet that has v naught in it. It has a, t, and v. Wow, and it's in order. If you look at your formula sheet, it's v equals v naught plus a times t. So what we want to do now is plug in the variables that we have and what we don't have. So we don't know v. That's what we're trying to find. We know v naught is 0 meters per second plus the a, 6 meters per second squared, times the time, which is 2.5 seconds. All right, and we want to multiply those two. Now, notice here you have seconds squared. That's in the denominator. And here we just have seconds. That's in the numerator. So it's going to actually do some nice canceling for us. So one of these seconds cancels out with one of those. Okay, do this math. Multiply 6 times 2.5. And I'm going to pause it while you do that. So when you multiply those together, this is 0. So your v is going to be 15. In your units, you have meters per second. Okay, you've canceled out one of the seconds here, and that second there is canceled out. So velocity is a displacement over a time. Okay, position over time. That's what this unit is. Circle your final answer, or highlight it or underline it, something like that to make it stand out. So notice what we did in this problem. We listed our variables knowns and unknowns. We wrote a formula. We showed our work where we plugged everything in, and then we showed our answer with the units. All right, for every problem, this is what you want to do. On a test, on a quiz, on any homework, this is what you want to do. You want to show all of your work. All right, let's try this problem. An airplane flying at a velocity of 165 meters per second accelerates at a rate of 7 meters per second squared for 5 seconds. How far does a plane travel during the 5 seconds? Okay, I'm going to pause this for a second so you can list your knowns and your unknowns. Remember, we're just using the kinematics equations in your formula sheet section, that first top left section. Okay, so if you get to that part and you've listed your knowns and unknowns, write down what formula you think you're going to use for this problem. At this point, you should have listed your variables from the problem. V naught, 165 meters per second. Your acceleration is 7 meters per second squared. Your time, 5 seconds. And then x, you're trying to find how far, I underlined how far. How far did it travel during that time frame? And the only one of those equations that you can use for what you have is x equals v naught t plus 1/2 at squared. You've got to take into account the time. You can't use the first formula because there's no x in that. You're not finding how far. All right. The second formula is the one that we're using. The third formula doesn't have time. Okay. And the last formula, we don't have a final velocity. So you've got to use the second formula. Now I want you to plug in the variables, or plug in the numbers into the variables. Okay, do that. Once you've plugged everything in, it should look like this: 165 meters per second times 5 seconds plus 1/2 times 7 meters per second squared times 5 seconds squared. In this formula, t squared, okay, you're only squaring the t here. So you're only squaring the 5 seconds. So you're squaring the number as well as the unit. So in my head, I know it's 25. Okay, but it's 25 seconds squared. The unit also has to be squared. Okay, so let's try to do this math right here, and then I'll pause it while you do the math and then show you how the units cancel out. Okay, so in the first half of this equation, 165 times 5 is 825 meters. Notice you have seconds here in the numerator, seconds here in the denominator, so when you multiply them, they cancel each other out, and you're just left with meters. Over here, seconds squared and seconds squared. This, with the 5 seconds, is going to be in the numerator. With the 7 meters per second squared, it's in the denominator. So the seconds squared canceled out, and you're only left with meters. So 25 times 7, half of that is 87.5. Add those two numbers up, and your distance or displacement the plane travels in that 5 seconds is 912.5 meters. So you listed your variables, knowns and unknowns. You wrote down the formula, showed all your work, and then circled your answer with the units. All right, so make sure you're checking these to make sure you're correct. Our third and final problem: a model airplane needs to achieve a velocity of 20 meters per second before it can take off. It is capable of accelerating at a rate of 8 meters per second squared. What is the shortest runway that can be used to operate this plane? So runway, shortest. We want to know how far it can go, the shortest displacement it can travel or distance. Okay, so if we know that, we know we're trying to find x. Okay, so I want you to list, there's your unknown, but list your knowns and then look at the kinematics equations and see which one of these formulas will work for this. This is probably one of the hardest problems you're going to come across because there's a lot of math involved in this. Okay, so we're trying to find the horizontal displacement. The model airplane needs to achieve a velocity of 20 meters per second. So that's its final velocity. Before it takes off, you know that it's at rest. So the initial velocity is 0. And it's accelerating at a rate of 8 meters per second squared. The only formula, okay, the only formula out of those four that does not include time is this one: v squared equals v naught squared plus 2ax. Make sure you're always bringing your calculator from now on with you to class every day. All right, so take these numbers and substitute them in. This is what it should look like once you substitute everything in. Okay, so let's start at the left. Let's do 20 meters per second squared. So on your calculator right now, plug in 20 and then square it. So you should get 400, okay? 400 meters squared per second squared, because you've also got to square those units. Well, this 0 cancels out, okay? We don't even need that. But we know 2 times 8 is 16 meters per second squared times the quantity x, okay? That's what we're trying to find, all right? We're trying to find that. From here, we want to divide both sides by 16 meters per second squared, okay? We want to get rid of that so we have x all by itself. So let's divide both sides by 16 meters per second squared, right? So this is going to cancel out. So you're just left with x over here. And on your calculator, do 400 divided by 16. And you get 25. Now, let's look at the units. Okay? Second squared, cancel. Meters squared, so one of those cancels and that one cancels. So on the top, in the numerator, you're left with meters. Is a horizontal displacement have a unit of meters? Is that a length unit? Yeah, so 25 meters. Does that make sense? 25 meters is the answer to that. That doesn't make sense. That's way too short. So let me check my math, okay? 400 divided by 16. Nope, that's right. It's a model airplane. In my head, I was thinking it was a real airplane. So 25 meters, okay? There's your answer. Circle that. And that is the end of your acceleration problems. Keep practicing these until you get good at them.